screen now.
Perfect.
All right, I am Abe Leite. I am with the Evolutionary Adaptive Systems Group in Indiana University, Bloomington, USA. Today I'm going to be presenting some work exploring reinforcement learning beyond the Bellman equation with exploring critic objectives using evolution. So where do we start? We know that in natural systems, we acquire adaptive behavior using both lifetime approaches and evolutionary approaches. And from previous Alife work, we know that lifetime learning can guide evolution virtually as well. However, much of this work in artificial life has been shown in abstract fitness landscapes rather than in behavioral situations. In our work, we're going to combine a lifetime reinforcement learning algorithm with an evolutionary approach to solve an embodied behavior using a neural network. We're then going to analyze the difference between lifetime learned approaches and evolution combined approaches. In order to do this, we're going to be taking an actor-critic model, as is common in reinforcement learning. Our pure RL approach is going to be deep deterministic policy gradients, which is an implementation of Lillicrap and al.'s work. In this approach, we have an actor which provides a sensory motor map. It takes in a sensory stimulus from an environment and then uses that to produce a motor output. The actor receives training signals from a critic, which takes states and proposed actions and returns a quality assessment. In reinforcement learning, the critic is usually fitted to data from the environment. It's determined to fit the long-term anticipated reward of taking any given action using what's called the Bellman equation. On the other hand, in our hybrid approach, we're going to similarly take an actor-critic model, but we're going to use a number of critics and a number of actors. Each critic will be responsible for training one actor. Rather than fitting the critic to reward signals from the environment, we will optimize the critic using a population search, and the critic's fitness will be assessed using the performance of the actor in the environment. This allows us to compare the representations that we get on an embodied task from a fitness-based approach and a fitting-based approach. We use the inverted pendulum task, in which the agent receives the x and y coordinates of the tip of a pendulum and the angular velocity of the pendulum, and is responsible for outputting the torque that is going to make the pendulum point straight upwards. We develop critics using both of our two approaches, and then we analyze them in the following ways. We check whether each critic is fit in the sense of EQ, whether the critics from both EQ and DDPG are able to train new actors when the critic is left fixed. We compare the training signals that the critic provides to the actors over the full state action space, and we compare the direct representations. What function is the critic encoding? When we develop our critics, we find that both algorithms lead to good performance on the inverted pendulum task. We take, for each case, 20 populations of 160 actor-critic pairs each. In EQ, these populations evolve with the individuals exchange information through evolution. In DDPG, the individuals learn independently. We use small critic neural networks with 4 inputs, 20 and 10 hidden units, and then a single motor output, and large actor networks, as in the DDPG case. We then select the best run-end actor-critic pair from each population, and we extract the critic from that pair for further analysis. When we begin to do this analysis, we find that all critics are indeed fit in the sense of our EQ approach. Critics from both methods are able to train new actors effectively. We take 10 newly initialized actors for each critic, and we find that over time, the EQ critics are able to train actors very quickly, which makes sense since they were optimized to train over 50 episodes. However, we find that there's a crossover point, and DDPG matches its performance around 250 episodes. at convergence, there's no statistically significant difference between their performance. On a functional level with the training signals, we find, again, that all of the critics are similar. When we take a correlation matrix of the training signals from any two EQ critics, any EQ critic and any DDPG critic, or any two DDPG critics, we find that all of these are moderate positive correlations. When we perform a clustering analysis on each individual critic's training signals, we find that the EQ and the DDPG critics intermingle, that there is no specific, it's not that all of the DDPG critics cluster first and all of the EQ critics cluster first and then they finally combine. Rather, they intermingle throughout. However, on a representational level, we find that the EQ critics are far more diverse than the DDPG critics. In terms of the state action quality assessment, we find that any two EQ critics are virtually uncorrelated, and likewise for any EQ critic and any DDPG critic. However, two DDPG critics exhibit a very strong positive correlation with each other in their state action quality assessment. When we perform a clustering analysis, we find that all of the DDPG critics cluster with each other first, and then cluster with one subpopulation of the EQ critics, and finally cluster with another subpopulation of them. This indicates to us that the DDPG critics may occupy a very small portion of the representation space, whereas the EQ critics may occupy a much broader portion of the representation space. Therefore, our primary conclusion to our Venn diagram question is that it appears to us that the DDPG critics seem to satisfy the conditions to be EQ critics, but that there are far broader space of EQ critics than there are DDPG critics. To summarize and conclude, our initial goal was to evaluate the benefits and the contrasts of a hybrid approach to reinforcement learning versus an individual reinforcement learning approach. In order to do this, we used two algorithms, DDPG and evolved QMaps, and we compared the critics from these two algorithms based off of performance, based off of function, and based off of their direct representations, the functions that they encode directly. We found that both the DDPG critics, the individual learning approach, and the EQ critics, a hybrid approach, appeared to have similar functions and appeared to both be apt and fit. However, we found that the hybrid approach found a much broader set of adaptive critics than the pure reinforcement learning approach using the Bellman equation. This is what one would expect, given that the Bellman equation is a very, very narrow data fitting approach and that EQ is rather unconstrained. This leads us to conclude that we have found additional evidence in support of the emerging trend all throughout artificial intelligence towards algorithms generating algorithms. Some of our future directions are to apply similar hybrid approaches towards other RL architectures, such as value networks or learning rule-based approaches. Also, an additional further approach may be to analyze our evolved critics to look for additional possible critic objectives other than the Bellman equation. I would like to thank my collaborators, our reviewers, and all of the financial support that we received from various funding agencies. I can now take questions.
Thank you, Abe. That was a very clear and great talk. Any questions in the audience? I had a quick question that came up early, and people can raise their hand if they have more. But I think you explained it later on, but when you were comparing the performance of the individual learning and hybrid approaches, and you said they were not statistically different, it did look like the hybrid approach had a much wider variance. So I assume you meant that the average was not statistically different.
At the end, the variance was similar.
Okay.
I'm not certain why this one is different than this one, but this is definitely the data that I was working with.
But could that also be what your main conclusion being, that you get a wider range with the hybrid approach?
That's very possible, but we would hope to have a wide range of equally adaptive approaches rather than a wide range of how well or poorly they do.
Right.
But yeah, we did Welch's t-tests, so we didn't assume equal variance, and we found that we found pretty large p-values in this case.
Oh, okay, so that might just be that one run. Okay, thank you. Any other questions in the audience? So just some comments. I think people like to talk, so thank you again.
Cool. All right, thank you very much.
I'll welcome our next speaker, Thomas Helmuth, to share their screen and start when they're ready. Thomas will be talking about explaining and exploiting